Hello, this class is on routing. So today we will go over, for routing, we will go over learning objectives, why do you need it, exercises, learning verification, and summary. First, we'll go over our learning objectives. So after taking this training, you'll be able to answer these questions. Where is a packet in the same subnet directed to? Where is a packet in a different subnet directed to? Where is a packet to the host itself directed to? Why do you need it? Well, routing is needed to get stuff from one network to another network. While switching works within a network, routing works between networks. What is routing? That's a good question. Routing is the process utilized to determine the best, dependent upon arbitrary criteria, way and/or ways to get traffic from a source to a destination. Routing, by nature, is asynchronous. This means that the path taken to get from point A to point B may not be the same path taken in reverse to get from point B to point A. It is recommended that these paths be the same, but routing is based on destination, not the source. Exercise 2 is Is routing based on destination only? Actually, it is possible to have source-based routing, but most networks prohibit this behavior as they lose control over pathing through their networks. Routing is a lot easier to understand once subnetting is first understood, and that's why you are taking through subnetting courses first. One could do fancy things with routing based on policies, but this class isn't about that. Exercise 3, understanding routing. Aren't default gateways all we need? Well, default gateways are perfect if they are your only connection to another network. Routers are designed to sit between networks and handle getting traffic from one network to another one. Thus, your default gateway is a router, but is not quite what you need for something such as the internet to work. Exercise 4, understanding the Windows routing table. So the question becomes, what do these columns mean? The command here used in Windows is route print. As you can see, it shows you this IPv4 route table, and it says here active routes. So there's a network destination, there's a network mask. This is the same as what you would consider a subnet mask. Then you have a gateway, an interface, and a metric. So what do all these columns mean? So they'll be explained. So the network destination refers to the network address. The net mask is a subnet mask. The gateway is the address used for reaching that network. The interface is the interface used to reach that gateway. And the metric is the cost to reach that network. So keep this in mind while looking at this output here. Keep that in mind. What about the on link in the gateway column? So looking at this gateway column, we see on link here. On link means that the destination is on the same network as the host. Basically, it means, you have a network in common. Thus, any networks that match up to an on-loop gateway mean that the host will utilize Address Resolution Protocol, ARP, directly to reach these destinations. Exercise 6. What if the destination does not match an on-link network? Well, that's a good question. What if that happens? Well, if the network does not resolve to unlink, then it must inevitably match the default route, and the host has to use address resolution protocol to resolve its gateway IP address to a MAC address and then forward the traffic to its default gateway. Exercise 7. Understanding the routing table. What do these net masks mean? There's this 0.0.0.0 as we see here, and there's also this 255.255.255.255 as shown here, 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 and here. What does that mask mean? Well, the net mask of all zeros means that nothing is required to match. The net mask of all 255 means that all bits must match. What do 0.0.0/0 172.16.5.10/32 and 172.16.7.255/32 mean? So that's referring to this network destination with this net mask is considered /0 because, as you'll note, no bits are turned on here. Now, when you look at this one, 172.16.5.10, as you can see, all 32 bits have been turned on. If you translate this decimal subnet mask to binary, you should return the result of all ones. And this one also has the same subnet mask. So now you're wondering, what do these mean? Now this they call this the quad, usually they refer to this as a quad zero network. /0 refers to this network. This network with this net mask. This 172.16.5.10/32 refers to this network with this net mask. And 172.16.7.255 refers to this network with this net mask. Okay, a good question. What is the network address and broadcast address for this host? Here we have some command output from ipconfig, and we can see an IP address, a subnet mask, and a default gateway. And the question being asked is, what is the network address and what is the broadcast address? That's a good question, because if we know what we're doing, we should be able to figure this out. Well, in this case, the network address is 172.16.0.0, and the broadcast address is 172.16.7.255. And funny enough, you will notice these both will appear in the route table. Interestingly enough, these will both appear in the route table on a Windows host. Nice, huh? Now, where will the system send traffic destined to 8.8.8.8? Answer on the next slide. So if you're wondering how to read this, this shows you a network destination, then you see a subnet mask here. You see the gateway that would be used and what interface would be used and a metric. So you'd want to look at, hey, so I need to get to such and such location. Which interface will I use to get there? So your subnetting skills come into play to understand this question. Now, here's the answer. The answer is 172.16.0.1. That's the one that will be used to send traffic destined to 8.8.8.8. Now, you may first look at this one, the 8.8.8.4/30, because this subnet mask has the first 30 bits turned on. If you're not understanding this, you may want to go back and review the subnetting series. There's 4 subnetting videos I'd recommend reviewing. So you will be able to instantly know that this is 8.8.8.4/30. Now this 8.8.8.4/30 network looks appealing, but if you understand subnetting, you will realize this. The network address for this combination will be 8.8.8.4 for a network address. The broadcast address will be 8.8.8.7. So you will notice that 8.8.8.8 does not fall within the range of this network. So you can't use this route at all, and it would instead use this route and send it to 172.16.0.1. Exercise 11. Where will the system send traffic destined to 8.8.8.9? answer on the next slide. Okay, here again, we have an opportunity to send some traffic to a particular network. We have this route here. And you see we have gateways, interface, and metrics, and we have network, we have subnet mask, and we have this network here. We're going to here, and this metric, you know, whatever. I believe earlier we did explain that the lower metric was better. But let's see what really happens. So, actually what's going to happen is it will actually send the traffic to 172.16.8.8. And once again, to understand this, you need to use your subnetting skills. And beyond subnetting skills, you need to know the title of this slide is longest prefix match. So that was a big hint as to what the answer really was. But in this case, we'll go over it still. So the prefix for this 8.8.8.0/28, which is this line here, this is a /28, covers 8.8.8.0 through 8.8.8.15. So 8.8.8.9 falls within there. Now this one is 8.8.8.0/27, which is this one, covers 8.8.8.0 through 8.8.8.31. So 8.8.8.9 also falls within this one. This one, the prefix 0.0.0/0, covers 0.0.0.0 through 255.255.255.255, which is referring to this one here. So that actually means that all of these could go to this particular destination. But since we said our criteria was longest prefix match, this one is the longest prefix that also will match that destination you're trying to reach, because it fits with it here. So the longest prefix match is what you would want. That is, it will be the closest match to what you're looking for. But remember, it has to be closest match based on the prefix being longer and also including the destination. So this would be the one chosen. Thus, it would choose this one right here. Now, exercise 12, what about the metric? Because the question becomes, why is the route with worse metric better for reaching 8.8.8.8? Because since we're experienced now, we can at a glance look at these and say, oh, well, they're both network, destination, net mask. Okay, 8.8.8 falls within both of these. And this one has the longest prefix match, but it has the worst metric. And earlier we did say a lower metric was better, so why are we providing this seemingly conflicting information? But I will explain why. Now, actually, the routes will be evaluated in a certain order. The longest prefix match will be matched before metric gets considered. So metric would only come into play if routes were of equal prefix length. Since this one has a longer prefix that matches where you're trying to get to, this route will be used over this one because the prefix is longer. So longest prefix match occurs first, then if that's all things equal, then we will look at metric. Okay, now that gives us an obvious follow-up question. What about identical routes? In this case, we have the same network mask, the same metric. The only thing different is the gateway and interface. So what are we going to do in this case? Interestingly enough, actually both paths will be chosen, and depending upon the routing protocol in use, you could actually load balance amongst the multiple equal cost paths. So it may be possible to load balance and use both of these links. Exercise 14 of 15, ping. In this case, we will ping the default gateway and notice what shows up in the ARP table. We will also ping 8.8.8.8 and notice what shows up in the ARP table. Now, as we'll notice here, we pinged the default gateway. Even though it didn't respond, we still got an entry for it in the ARP table, because if we could not get an entry for this default gateway in our ARP table, we would not be able to send traffic outside our subnet. We've covered that previously. Here we pinged 8.8.8.8, we get a response, but as you'll note, there are no entries for it in the ARP table, which should have been explained previously when we went through ARP and we went through subnetting, that you would not get an ARP entry for something that's not within your subnet. And 8.8.8.8 is not within the same subnet this interface is attached to. Exercise 15, Traceroute. Now, in Windows, we're going to do a traceroute to 8.8.8.8. Okay, here we did a traceroute and we had some flags turned on, as Kelly likes to say. Now, in this case, the flags that were turned on were this -D to mean don't use DNS to resolve with these. Don't try to do DNS resolution for these. -W at 200 for actually waiting 200 milliseconds. And -H for 10 was only show me 10 hops, as it shows trace and route over a maximum of 10 hops to this destination. So when we did this trace route, we got this result, and these are the different hops along this path to get to the destination we're trying to reach. Now, learning verification. Where is a packet in the same subnet directed to? Where is a packet in a different subnet directed to? Where is a packet to the host itself directed to? Summary. A packet destined within the same subnet will be sent directly to that host. A packet destined outside the same subnet will be sent to the default gateway. A packet to the host itself is handled by the local networking stack on that system. Routing is normally based on destination. Source-based routing is possible, but not permitted on most networks. If you cannot get outside the subnet, verify that the IP address, subnet mask, and gateway are correct for the host. Traceroute can be used to discover routing issues. It should be noted, traceroute results may not reveal all network hops, because some devices may be transparent to traceroute. Now, routing must be checked in both directions. Just because it got there doesn't mean it can get back. And that concludes our class on routing. Thank you so much.